Thank you. Good evening, everybody. So I will talk about the effect of the vessel, as Pierre-Louis said. Thank you for your introduction, and I would like also to thank IVES for this invitation. And obviously, I will talk about the vessel, but it could be obvious, but wine is a liquid, and obviously we need a container to keep this wine. And all the liquids has constant volume, but variable shape. So the liquid will always adapt to the shape of the container, obviously, as all the liquids does. So as Pierre-Louis say in the introduction, there are a lot of winemakers that are using these new fashionable vessels to make their wines, and they have some reasons to do that. So traditionally, these are the most employed vessels during the last decades in the wine industry. So basically, stainless steel tanks, really, and also oak barrels. And they are antagonistic tanks from several points of view. For example, from the point of view of the release of sensory active compounds. So stainless steel does not release these compounds, while all we know that oak barrels does. And they are also antagonistic from the oxygen point of view, because stainless steel do not allow oxygen pass through the material. So the wines are more protected from oxygen, and oak barrels does. So one of the reasons that winemakers say that they are looking for new vessels that allow them use materials that do not release these active sensory compounds, but allows oxygen to be in contact with the wines. And the main reason is because some winemakers don't want to use oak barrels just because they want to preserve the intrinsic properties of the wine. So they want to preserve the varietal typicality and also the terroir typicality. And some winemakers think that using oak barrels, they are hiding the intrinsic characteristics of the wine. And this is the main reason to use this new kind of vessels, because they think that they do not release the same aromas and the same tannins as wood, but they allow oxygen to be in contact with the wines. And we know that a little bit of oxygen allows some wines to reach their higher or their best expression. So when I arrived at Chile in 2014, I visit a lot of wineries, and all the wineries has almost a couple of these vessels. And I started to look for some scientific information about which is the effect of using these vessels, and I cannot find anything at that time. And so when I finished my postdoc, I applied for a project regarding to address this issue, to know which is the impact of the vessel. And we get some funds from the Chilean Agency of Research and Development. And this is the code of the project. And I will start by the acknowledgements. All these people is all the researchers, all the team that collaborate with me in this project. Cristina Úbeda, at that time she was working with me in the Universidad Autónoma, but she's nowadays working in the Universidad de Sevilla in Spain. And also Álvaro Peña and José Ignacio Covarrubias, they both are working in the University of Chile. And also Felipe Lorí, that is working in the University of Talca. I also need to thank the Miguel Torres Winery in Chile, because we performed the trials in their winery. And for me, this is very important. The trials and the results that I will show are not results that we obtain in the laboratory, but they are results that we obtain in the cellar, in the winery, and they manage the wines. So our results are representative about what is happening actually in the cellar, in the winery. So just a summary, we have more results and more different trials, but I will talk to you about what happens during the alcoholic fermentation when we use these different kinds of vessels, and also what is happening when we age the wines on their own lees using these different kinds of vessels. And to finish, we will talk about some conclusions. So regarding the alcoholic fermentation, obviously there are not a lot of information, as I said before. I just will explain you which are the trials that we made and which are the results that we obtained. So we use Sauvignon Blanc grapes. Basically, we want to try with white wines because the chemical composition of white wines are easily to understand what is happening with the wines for us, because the red wines have a more complex composition. And we choose Sauvignon Blanc because in Chile, white wines are mainly Sauvignon Blanc and Chardonnay. But people used to like using oak barrels with Chardonnay, but people don't use oak barrels with Sauvignon Blanc. So it has sense for us to work with Sauvignon Blanc in this case, trying these alternative vessels to oak barrels. And the grapes that we use, these are grapes from the Miguel Torres winery. They come from the Limari Valley. This is a region that Gerardo showed this morning. This is one of the blue labeled valleys. So it can be considered as a cool climate valley because it is very near to the coast, and at that latitude, the Pacific Ocean is very, very cold. And so it is a cool climate, but we have, as Gerardo said, low differences of temperature between the day and the night, and it is a very wet climate also. This is a proof about this cold climate origin of the grapes. So April in Chile is like October here in the North Hemisphere. So considering that it is a wide variety, it is a very late harvest. So the general parameters of the grape juice I included here. You can see the bricks, the titratable acidity as tartaric acid equivalents, pH, and so on. The grapes are processed by the people in the winery Miguel Torres as they used to process these grapes every year. So it is a conventional white wine vinification. They destemmed and pressed the grapes, and then they fill a great tank. I think that it was 10,000 liters tank, and let them in cold during 24 hours to let the solid particles to settle. And we just use the clear mass, the clear grape juice of the top of the tank to fill different kinds of vessels. We have 4 different kinds of vessels, but we have not just one of each type, but we have 3 of each type, because this allows us to make some statistical analysis of the results and better understand what is happening when we use these kinds of vessels. These are the characteristics and the manufacturer of the vessels. Obviously, this is not a perfect experiment because we have not the 4 vessels with the same volume. This is related with the budget, but also with the commercial available tanks that we can purchase in Chile. But all of them are commercially available in Chile, and they are used by a lot of wineries and a lot of winemakers. So we have cylindric stainless steel tanks. We have also 2 kind of ovoid tanks, one of polyethylene and one of concrete. And finally, we have also clay jars. I forget to say you something. We should take in account that the opening of these containers are very different. So the opening of the stainless steel tanks were narrow, especially if we compare the opening of the other kinds of vessels. And this will be important to discuss the results that we obtained. So basically, the trial that we make is after filling of the tanks aleatorily to avoid some differences due to the stratification of the grape juice. we perform the alcoholic fermentation. Again, the commercial starter of yeast is the yeast that people in Miguel Torres use to ferment these wines because they think that this mixture of yeast allow them to enhance the thiolic characteristics of this Sauvignon Blanc. And we obviously take measurements of the density and temperature daily to follow the alcoholic fermentation. And once the alcoholic fermentation is finished, we just take a sample, 5 liters of wine from each one of the tanks. We sulfited them, and we also make a cold stabilization to stabilize the tartaric acid salts. And finally, after this tartaric stabilization, we bottle the wine. We, if I can remember, it was 6 bottles of each tank, finally. And there is a mistake. We don't use natural cork. We use green glass bottles, but like sparkling wine bottles, and we use crown caps. And I will use the same colored labels for all the presentations, so we keep here the legend. And what happens with the alcoholic fermentation? This is the average density of each triplicate, depending on the kind of vessel that we employed. And clearly, the wines fermented in the stainless steel tanks where in that tanks, the alcoholic fermentation was slower, was significantly slower. So it takes 5 more days to ferment the wines for these stainless steel tanks than all the other ones. And we related these results with the opening of the tank. So since this stainless steel tank has a narrow opening, finally, we think that probably the evacuation of carbon dioxide was more difficult. And then the yeast has low amounts of oxygen for the fermentation. When the alcoholic fermentation is finished and we analyzed the wines, surprisingly, we observed that both oval kind of vessels showed the higher amount of reducing sugars and the lower amount of volatile acidity. So the volatile acidity, we think that it is very normal since the fermentation was shorter. There are less time with the active metabolism of yeast, and then we have less production of acetic acid. This is quite normal, but we cannot explain very good these results about the reducing sugars. If we look at the acidity of the wines, we observe that clearly there's an effect about the material because we observe that the concrete vessels show the higher pH and the lower titratable acidity. I didn't mention before, but these concrete and clay vessels were uncoated. So we performed a treatment with aqueous tartaric acid as the supplier recommends, but they are not epoxidized or something like this. So the wine is finally in direct contact with the material, with the concrete or with the clay. And since wine is an acidic solution, it is well described that the acidic solution can dissolve some of the materials of the concrete or even of the clay. In this case, during the alcoholic fermentation, we have not evidences of a release of inorganic materials from clay to the wine, but we have clearly evidences that there is a dissolution of inorganic compounds from the concrete to the wine. Besides, we observed that the polyethylene tanks and stainless steel tanks showed the highest concentration of tartaric acid. And the other tanks obviously has the lower. We related these results with this contact of the wine with these porous inorganic materials. So probably the inner surface of the clay and concrete could act as seeds for the growth of tartaric acid crystals. In fact, when the alcoholic fermentation is finished and when all the trials are finished, we can observe some crystals of tartaric acid in the inert walls of the tanks. Regarding the elemental composition of the wines, first of all, we measured the conductivity of the wines. And again, we have clear evidence that concrete are releasing some inorganic salts into the wine because the conductivity is statistically higher for wines fermented in the concrete vessels than each other kind of vessel. Besides, we can observe that we have in the most of the elements that we analyzed, the concrete wines has the higher amounts, with the exception of calcium. By some way, it seems that this concrete favors the precipitation of calcium tartrate in comparison with the other kinds of vessels. For microelements, it is the same thing. We can observe that basically the concrete wines has the higher amount of these elements, supporting the idea that effectively the concrete is releasing some inorganic salts to the wines. Regarding the volatile composition, I will not show each and every volatile compound that we analyzed because I am chemist, I love chemistry, but maybe you are not. We grouped these volatile compounds according to their main functional group, according to their family, and we just observed differences for esters. Esters are responsible of the fruitiness of the wines. And if we look which esters showed differences, we can see that the acetate esters and ethyl esters that are related with yeast metabolism showed statistical differences, being the stainless steel tank and concrete tanks, those has the greater concentrations. If we also have some other analyses considering the structure of the compounds. I will not talk about all of them, but I think that there are some interesting results here. First of all, we analyzed which are the amount of 6-carbon compounds because they are traditionally related with herbaceous scents and vegetal aromas. And we can see that there are differences here. And being, again, the stainless steel vessels and the concrete tanks, those showed the higher concentration. And in contrast, we also realized that there are statistical differences considering the 7-carbon compounds. And this is quite interesting because we used to relate the aromas from yeast with compounds with an even number of carbons. So these compounds has an odd number of carbons. We are related this with primary aromas, with aromas that came from the grapes and not just from the yeast. And again, we observe some differences, but in this case, the stainless steel wines and the clay jars wines, where those show the higher amounts of these C7 compounds. Regarding color, we didn't observe differences. You can see some statistical differences here, but these differences are very, very low, and they are not distinguishable through the glass. So they have very pallid colors. They have, look at this L, so they have no a deep color, and they are not distinguishable. So we can say that we did not observe differences on color. And regarding the phenolic composition, we mainly found, we analyzed the low, the phenols with low molecular weight, and we mainly find hydroxycinnamic acids. Again, we have not evidences of differences according to the type of vessels on the total amount of these hydroxycinnamic acids. But that's true that we can observe some differences according to the esterification pattern of these compounds. Regarding the colloidal fraction, we measured the turbidity, and we did not observe differences on turbidity of the wines. This is fun because some enologists they use this kind of vessels, especially the oval-shaped vessels, because they say that there are more convection currents and the Coriolis forces are pushing the macromolecules, and we cannot observe differences in turbidity in this case. We also analyzed the protein stability by using the fast heat test, because Sauvignon Blanc is a variety that could have some problems of protein stability, and all of them were unstable. We measured the amount of bentonite required to stabilize the wines, and again, it seems that the oval-shaped vessels needs less amount of bentonite. So it is interesting results because it seems to point that the shape of the vessel, the geometry of the vessel, can influence the stability of the wines, the protein stability of our wines. And finally, for colloidal fraction, we also analyzed the polysaccharides. We quantitate the polysaccharides according to their molecular mass. This is the chromatograms that we obtained when we made when we fractioned them according to their molecular mass. But we didn't find differences on the polysaccharide concentration, nor in the total concentration, but neither for any of the fractions. So it seems that the alcoholic fermentation is not enough time to observe differences in this amount of polysaccharides. Finally, we also performed a sensory analysis. We employed a TriNet panel conformed with winemakers, Chilean winemakers, that are familiarized with these Sauvignon Blancs, coastal Sauvignon Blancs, and also some academics. And this is the profile that we obtained through this descriptive analysis. And we can observe some differences. For example, these polyethylene wines, they are more bitter than the other ones. And also for the concrete vessels, we have more vegetal scents and also more persistence. When we make a statistical analysis about these 9 attributes that we asked to the panel, we observe some statistical differences considering bitterness. So the wines elaborated, fermented in the polyethylene tanks are more bitter than wines elaborated in the oval concrete vessels. We also observe some differences in fruitiness, and being the concrete wines, those show the lowest fruitiness, and the wines from the stainless steel and clay jars are those has the highest fruity character. And if you remember, I showed you that C7 compounds that are related with fruity scents, and we related it also with primary aromas. So it is maybe a coincidence, but these kind of vessels show it the highest amount of these 7 compounds, and they are also, during this sensory analysis, those has the higher perception of fruity. So, which are the remarks of this trial? Basically, we did not observe differences on color, phenolic composition, or polysaccharides when we ferment these Sauvignon Blanc grapes in different kinds of vessels. But we observed some statistical differences for the alcoholic fermentation performance, acidity, elemental composition, volatile compounds, protein stability, and sensory analysis. But we have not clear trends, or we have not clarity about which is the reason, because we have not the same shape with different materials or the same material with different shapes. So sometimes it is difficult to know if the difference is due to the material or to the shape. But we are very surprised about these results, considering the performance of the alcoholic fermentation, the fermentation rate. And because of that, we make another trial. This is under construction, so I will show you just a preliminary results. This is a work of a master student of the Viticulture and Enology master in the University of Chile. And we tried to distinguish if the differences in the fermentation rate are related with shape or with material. And this is an experiment not made in the winery. We make this experiment in the laboratory. And we use borosilicate flasks, lab flasks, like this, with different shapes, but with the same material. And we use it also by triplicate, to ferment. We can trust these results despite the low volume because we can measure the density using an electronic densimeter that needs a very few amount of mass, so there is no oxidation in this case. And these are the results. And you can see that effectively the flask that has a round bottom ferments faster than the flask that has a flat bottom, finally. And this is statistically very clear. So it seems that effectively the shape is affecting the fermentation rate. Moreover, using this kind of flask in the laboratory also allows us to measure the oxygen contents by using this chemioluminescence device. And we put a spot here in the top of the liquid and another spot in the bottom. And we observe that in the bottom we have practically no oxygen during the whole alcoholic fermentation. I'm sorry, but this is not ppb, this is ppm. I changed the numbers, but I don't change the title. But we observe that these round bottom flasks also show the lower concentration of oxygen during the alcoholic fermentation that is related with this higher velocity during the fermentation. We make these experiments employing a Saccharomyces cerevisiae yeast, but also using a sequential inoculation with a non-Saccharomyces and after a Saccharomyces. And in this case, with the sequential inoculation, the results are not so clear, so we cannot observe such differences in the fermentative velocity. But we also observe for the round bottom flasks that the oxygen concentration is lower, but these differences are very low. So basically we can say, based on these results, that effectively the shape of the vessels influences the metabolism of the yeast during the alcoholic fermentation, and it influences the fermentation velocity and also the oxygen concentration during the alcoholic fermentation. And as I say to you, we will talk also about the aging on lees. In this case, it is exactly the same trial, the same wines, the same vessels. After the alcoholic fermentation, we take a sample, but we let the wines more time in the vessels. So in this trial, after the alcoholic fermentation, we let the wines during 6 months, aging on their own lees, so without drag the wines. And we made a single batonnage at middle aging, more or less after 3 months after the alcoholic fermentation. After this period of aging on lees, we take samples again, we sulfide the wines. Once again, it is not natural cork, it is a crown cap. And we bottle the wines, and after that, we analyze and characterize the resulting wines. Regarding acidity, it happens the same thing, so they are the same wines. We still observe the higher pH and the lower titratable acidity for concrete wines. In the case of the conductivity, we cannot observe differences on conductivity in this case, but this is related in that when we make this trial with aging on lees, we did not stabilize cold. We didn't make the cold stabilization. So these wines are supersaturated with potassium, and the driving force of the conductivity is potassium. So this is the main reason to do not observe differences on conductivity in this case. But since we observed some differences on tartaric and calcium contents, we want to see if there is a natural precipitation of tartaric salts during this aging on lees. So if we regard the elemental composition, macro elements and micro elements, basically we observe the same thing. Even the calcium contents of the concrete vessels is the lowest, considering all the kinds of vessels. And once again, it seems to indicate that this concrete is favoring the precipitation of calcium tartrate. But in general, we observe the higher amount of elementals of the different elements for the concrete vessels. However, after these 6 months of aging on lees, we observed an increase about the copper contents for clay jar. And we think that this is indicating that effectively the clay can also release some inorganic compounds to the wines if we let the wines in contact with the clay during enough time. Regarding the color and phenolic composition, it is the same, more or less, than what happened after the alcoholic fermentation. We didn't observe differences on the phenolic composition, mainly hydroxycinamic acids, and neither observed differences on wine color. So it seems that the vessel is not affecting the color and wine composition. Regarding volatile composition, we did not observe differences, statistical differences for alcohols and terpenes, but we observed some differences with the acid concentration and also the esters concentration, and as happens after the alcoholic fermentation. But in this case, the differences are greater. And clearly, the wines made and aged in the clay jars shown the lower amount of these volatile compounds. So they show the lower volatile compounds, but once again, if we look for these 6 carbon compounds and 7 carbon compounds, the differences are changed with, compared with the results after the alcoholic fermentation. Once again, the clay jar, once again, the stainless steel and concrete wines showed the highest contents of these C6 compounds related with herbaceous scents. And for the 7 carbon compounds that are related with these fruity scents, regarding, again, the colloidal fraction, we observe in this case some differences in turbidity, but this could be also related with the lack of this cold stabilization process. And obviously, all the wines were unstable from a tartaric point of view, but we do not observe differences on the drop of conductivity when we applied the mini contact test. So it seems that there are differences on the stabilization of tartaric salts depending on the vessel, but they are not enough to observe the statistical differences. And regarding polysaccharides, in this case, yes, we observed some differences on the contents of polysaccharides. So after 6 months of the wines into these vessels, we can observe these differences. But you can see here that the oval concrete vessels are not shown the higher amount of polysaccharides, but the clay jars wine is those show the higher amount, the higher concentration of these polysaccharides. And in our opinion, it is not related with the convection currents or something like this, but it is easier because it is related with the surface contact between the settled yeast, the settled lees, and the wine. So these jars has the higher surface of contact with these settled particles. And finally, we made a multivariate analysis. We have not sensory analysis in this case, but basically, we made a principal component analysis and also a cluster analysis. These gray globes are the clusters that we found. And we can say, basically, that the wines elaborate in the clay jars are the most distinctive, and all the other wines are quite similar each other. So the remarks of this trial, considering the aging of lees, is that we cannot observe differences depending on the vessel, on color, or phenolic composition, but we observe some differences on acidity, elemental composition, volatile compounds, and also polysaccharides contents. So to finish this talk, the conclusions are more or less these. Okay, so we found some statistical differences. We can say that the vessel affects the final chemical composition, but we prefer to say that this vessel can help us to modulate the chemical composition because, okay, the differences are statistical, but they are very small differences. So if we use a Sauvignon Blanc from the other field, probably the differences are greater than those we observed. Obviously, we can demonstrate that these uncoated vessels of clay or, or concrete release some inorganic salts to the wine. We observe some differences in polysaccharide content, but just for the experiment in which we have the wines 6 months into the vessels. And obviously, we also demonstrated that the shape of the vessel can influence the alcoholic fermentation performance. So this is what I want to explain you this afternoon. Thank you for your attention. I will be very happy if if you have any question.